Okay, so we're switching gears just a little bit for 3.6. This is going to do mostly with a calculator. So if you don't have your own TI-83 or 84 or Inspire, make sure you've downloaded the app. The most popular one I know is Calculate 84. Otherwise, even go to just an online calculator that you can Google. But what we're doing today is we're going to be given a set of data points. These data points can be set up kind of like a scatter plot, and we're going to find the line of best fit. So you've done this before for just straight linear models, but now we're going to do them with exponential, logarithmic, power, quadratic, logistic, all of them. And that's all we're going to do for this one. But we're going to do different than just that logarithmic. So basically we're finding the line that goes through this data the best. So one thing to make note of is that these are all the different kinds that we're going to be doing. So we want to make note of their shapes, because you see, we can see that these go in a straight line, so that would be a linear function. But if we don't know the shape of the function, then we're not going to know whether or not it would be a good line of best fit. So quadratic, we'll calculate some of these. Those are just a parabola. Can open up or down either way. We know exponential, kind of start low, go high, or start high, come low. Power models are really close to these and kind of have that same shape. Logarithmic is the inverse of exponential, so it kind of takes a curve and plateaus, or it goes this way and then plateaus. Linear is obviously just a line, and then logistic kind of makes this S-shaped function. So these are important to write down. Make sure you have these so we can make the best judgment moving forward. So we're going to have kind of some steps to follow in order to figure out the line of best fit or the best regression model. So the first thing you'll do is, and you can just kind of copy these down, is you're going to put the data into our list 1 and list 2. Then we have to determine what the shape of this function is. So we'll go, like if say it looked kind of like a swoop up, we might say, well, that kind of looks like exponential, also kind of looks like power, possibly even quadratic. So we'd go through the list, check all the ones that look like it, and test all those regression models. Okay, so that's number 3, is trying all the different regression models that look like this function. We find the best fit by saying what's the closest R squared. So R squared is the coefficient of determination. Basically, this is just a kind of thing measured in statistics to say what's the strongest relationship between the model and the data points. So it measures that. The closest you can get to 1 means that's the closest fitting model. Okay, so I'm going to show you how to do this on your calculator, but we are going to use the following data to find the model that best fits. Again, that's going to be the model with the closest R squared to 1, or coefficient of determination. Let's see if I can get all those in. Okay, there they all are. So first things first, you need to go on your calculator. Obviously, turn it on. Then you're going to go second, can't really see mine, second y equals. Okay, so you can't exactly see. Maybe if I turn, there we go, now you can see. So all you can see is my calculator right now. Whoa, I thought I had it. Try turning that back on. Okay, so you need to hit enter. Okay, I guess it's just not going to work for me. So either way, you need to hit enter on this stat plot. Your blinking light should be over the on button. If it's over the off, you need to arrow over to on and click enter. You should also have the very first graph selected. After doing that, we want to go to the Stat button, and then the first thing you should see pop up is Edit. We go ahead and we hit Enter on that number 1. So you're going to have, I'm trying to nothing's helping this pop up at all. If you already have data displayed in your calculator, like I do right now, okay, I'm going to bring this. You really just can't see anything. I'm sorry. You can kind of see the buttons I'm hitting at least. I am right now selected at the top line of my L1. If you click up where you're highlighting L1 and hit clear, not delete, but hit the clear button right over here, and then enter or arrow down, it'll clear that whole list for you. So same thing over to L2, up to flashing over L2, hit clear, and then arrow down. It clears out that whole list for you. So in L1, you need to put all of the X values. So in my list, that's 2, 2.5, 3, 3.5, 4, and so on. You hit 2 and then hit enter. And then 2.5 and then enter. And then 3 and then enter, and then just keep going. Okay, 3.5, 4, 4.5, 5, 5.5 until you get all the way down to 9.5. All right, and then once you are there, you can arrow over to list 2. And list 2 is going to be all of your Y values. So 1, enter, 1.2, enter, 1.3, enter, and so on. Just keep going down. If you miss one, be sure to go back and fill it in. Because if you do entirely miss one, and say you end up with uneven amounts at the very end of this, you're going to have to go find the problem. Okay, so like I said, when you get done, you should be on the same line for both of them. So they should both have the same number of entries. Okay, so now we're going to go to the graph button. Okay, so hit graph over here. You likely won't be able to see it, so you have to hit the zoom and then go down to the option that says zoom stat and hit enter. Then it should be popping up all of these different little dots. Yeah, I don't know what's going on. I can't get it to focus on this whatsoever. So you should be popping up all these little dots that form a swoop like this. Okay, so we have to say what kind of models fit this swoop. So right off the top of my head, I'm thinking, well, I know an exponential model might fit that, a power model, and that's probably it, because a quadratic has should also come up on this side, and it's not. So since I'm only swooping to the right, I'm going to say it fits an exponential and a power. That's because if we go back and look, our exponential model takes a swoop up, and so does our power model. So those are the two we're going to test. The way that we test these or find the regression model that's possible is we go to stat and we arrow over to calc, and now we're open up to all these different lists. So since we're going to be testing exponential first, you want to go down to what says EXP reg and hit enter. Okay, you have to enter a couple of times down until you're flashing over the calculate button. Enter one more time, and I'm getting an R squared of 0.995209. I'm going to record that down and come back to it. Okay, now we're going to go to stat again because we still have to calculate our power model. So we go down to PWR reg, and we hit enter and enter all the way through to calculate. The R squared on this is 0.933. Okay, and real quick, if you're not seeing R squared, you need to go to second and then to this catalog. Okay, so catalog is just above the 0, and go all the way down to what says diagnostic on. All the way down to diagnostic on, and you would hit enter and enter one more time, and then it should pop up done. Then you can go back and calculate these, and you will have your R squared value in there. Okay, so the model with the closest R squared to 1 would be the best fitting model. Very clearly, that's the exponential. So we're going to go back and redo our exponential calculation to actually get the model. Okay, it says this is y equals a times b to the x. So my a value equals 0.512. My b is 1.363. Again, I'm just pulling this off of my calculator. Obviously, you can't see it, but there's all these numbers up here at a, b, r squared, and r value. Again, pull your a and your b. By following the model that I'm given, I can write y equals 0.5 times 1.36 to the x power, and that would be my model. A way to go ahead and test this: go to your y equals button, type in this function. So 0.5 parenthesis 1.36 parenthesis to the x. If you go ahead and graph it, you should be seeing this line go straight through the majority of your points. What that's showing you is your line of best fit, truly is a line of best fit, going through all of these different points that you've plugged in. Okay, so it's kind of cool. You're seeing your points that you plugged in and the line of best fit that you just made to go through them. So if it's not going through them at all, you either plugged it in wrong, you wrote it down wrong, or you calculated it wrong. Okay, one of those is happening. So I'd go back through and check everything. But this is our actual regression model or line of best fit for this data. Okay, so we're going to try 2 more. The next one, I'm going to force you to use logistic model. Okay, so I want you to find the following data, the best fit model for the following data, or the regression model. But I'm telling you, I want you to use logistic. So I'm not really giving you a choice there. I just want you to use this one. So again, go to Stat, Edit, go ahead and clear out those lists. Do not delete them, only clear them. If you ever delete them, you'll have to call me over to help you figure out how to add them back in. Or if you're working from home, even more difficult, you're likely going to have to email me, and I can send you some videos on YouTube or something of how to add them back in. Or you'll just have to Google it. So I've got these data points plugged into my list 1 and then my list 2. So I'm told I have to use logistic. So I go to Stat, I go over to Calc, and I go through them all to my logistic, B on my calculator. I hit enter and I get all the way through it. So this is y equals c divided by 1 plus a e to the negative bx. Okay, so kind of a big function there. I'm given my a, b, and c. For logistics specifically, you're never going to get an R squared value. There is no current way to simulate the R squared calculation with logistic models. We typically are talking about nonlinear. We're looking at all nonlinear models, but logistics specifically is especially nonlinear to the point that we cannot have an R squared value for this one. So that's why I just went ahead and asked you to find logistic, just so you can use that one once. So my A value is 7.16, my B 0.068, C99.746, right? So with these, you round however you want. I truthfully did not even round here at all. I just grabbed the first 2 to 3 numbers after that decimal point. I would like you to round. I'm just pulling those first 3 because you can't even see what's on my calculator, and I apologize for that. So I do want to go to my graph just to see, one, what these data points are looking like. So if I go to it, again, go down to Zoom Stat, and you can kind of see that they're taking a curve up, and that kind of looks like a logistic. So if we go ahead and write out this equation, it would be y equals c, which is 99.74, all over 1 plus a, 7.16 times e. Remember, e is a variable. That's the variable e. It stands for an irrational number e, so we're not putting anything in for that. This is to the negative b, 0.068x. All right, that is a logistic model for that data points. Those data points, sorry. Okay, one more example. And this one again is just telling you, go ahead and find the best fit model. So go to Stat, hit Enter for edit, clear out those lists. Go ahead and put all the X values in for your list 1, all the Y values in for your list 2. Okay, whenever you're done with that, we're going to want to go to Zoom Stat again and graph it. So we're seeing this upward swoop here, okay? So if we go back to all of our different functions and what they looked like, an upward swoop is going to either be a logarithmic, could be logistic. We're not going to test logistic for this one. Logarithmic is going to be one of my first guesses for this, and we're going to see if that one works. Logarithmic, natural log, is what I'm thinking could be either of those, because the natural log function looks like the logarithmic. Okay, so let's go in and test stat. Let's do first ln. Okay, ln is going to be our natural log function. Again, natural log and logarithmic kind of go off of each other. So when we test one, we always test both. So ln reg is what I'm testing right now for those of you, all of you that can't see my calculator. ln reg. Calculating that, my r squared is coming up at 0.9933838. So I like to write down as many numbers as possible because sometimes these get really close, like down to the 100,000th decimal. I mean, way, way out there. So I write down as far as I can. That's a really good r squared value. So I'm not quite sure that anything is going to be able to beat this, but we're just going to try to see. Okay, so we go stat calc again. And to our logarithmic one. So we will find logarithmic under, let me see which one I want us to use. Sorry about that. So when we're testing models that look like this, for one, let's go back to all of our shapes. So When we tested this logarithmic one, right, that's in at the exact same time, that's testing that natural log function. Since one is just a variation of the other. So we're testing that upward swoop. So we're not going to test logistic for this because we don't see the bottom half of the swoop coming. So realistically, I'm not seeing many other functions that are going to look like that. So what we did was test the natural log or logarithmic regression, right? ln is that logarithmic regression. None of the rest of these kind of seem like they're anything close to it. So just for the heck of it, we're going to test a couple others just to prove to you that this is the line of best fit. So why don't you go ahead and test maybe the quadratic. See if that's anything close. That is an r squared value of 0.9913. Okay, so just off by 1 decimal point, right? 993,991. So that r squared for logarithmic is still closer. So we know linear is likely not it because it's not a straight line, but we can go ahead and test it. R squared for linear is 0.899. So not very close to 1. So when we're looking through the 3 that I've tested, you can test all of these if you choose to, but logarithmic is coming up as the best. So I want to go actually get the function for that. If we go back and test it, we can see that it is y equals a plus b natural log of x, having us with an a value of 1.57 plus b 8.36 natural log of x. Okay, so for this function, that logarithmic is the best fit model. And again, you could go ahead and plug this into your calculator, your y equals button, and you could see that this actually goes through all of these data points really seamlessly. All right, so this is a lot of different calculator work, so if you're having troubles with it, please let me know. I apologize that you can't see my calculator, but just make sure you are trying these on a calculator. Thank you.